we have seen that machine learning can help us with classification and regression problems. And till now, we've been majorly focusing on supervised machine learning. So now in this video today, we'll be talking about unsupervised machine learning. And we'll be using unsupervised machine learning, specifically K-means clustering, to cluster our segments, our customers on the basis of the data that we have about our customers. So in K-means cluster, what we really do is we try and understand and cluster our different customers into different clusters which are not defined prior hand. Okay, so if you were to right now, if you are targeting your customers with the demographic information like male and female, or you're doing psychometric targeting using unsupervised machine learning and using the labels that machine learning algorithm gives you, you should be able to then figure out like some hidden patterns in your customers data. So if you have, let's say, the total spending from a customer, and you know the gender and you know their income levels, and you put all that data into a machine learning algorithm can then cluster information and cluster your customers into different clusters, and then you should be able to then figure out that this cluster number one has an average income of has primarily males in it, and has an average income of more than $10,000 in a year, and like that. Okay, so what I'm trying to make you understand is this way you should be able to then capture not just one trait and target on the basis of that. You should be able to then combine different possibilities of different traits and affinities or demographic information that you might have of your customer into logical segments. Some might not make so much logic, but some might do, and that's our job to find and understand what is making sense and what is not. So the way K-means algorithm will work is you plot all your data. Like right now, I'm just talking about 1D data. Okay, on one dimension, you have a line, and on that line you have a lot of plots. Okay, you have lot of data points, rather I should say. Once you have a lot of data points, you know that these data points can be clustered. Right now, let's say for example, we are doing clusters with k is equal to 2, which is right now we are just taking two clusters. In k means the number of clusters. So in K-means cluster, right now we're taking two clusters. We will define those two clusters and say and calculate the clusters that all the points will belong to on the basis of their nearest cluster. So let's say for example, there is this data point and this data point, and we will be calculating the distance of that data point from both these clusters and understanding, yeah, this belongs to this cluster because this one is the nearest. And post that you've done it for all the data points that you have in this 1D in this one dimension. Now what you do is you then after you have two clusters, you then calculate the mean of that cluster. Once you have the mean of those clusters, then you do the same exercise again, basically calculating the distance between all the points with the center, with the mean of that cluster, and you do that till the point the clusters don't change. Okay, there will be some change in the cluster because of the fact that one point which was near to another cluster has by chance fallen into another. So if you repeat this exercise and repeat it for multiple dimensions, we'll be doing it in 5 dimensions in the coming up exercise. And so it is easier to understand it on one dimension and then scale the concept up in 5 or 6 dimensions, but difficult to visualize it in 6 dimensions or 5 dimensions. So let's dive into the practicals, enough of the theory. So guys, today we'll be talking about customer segmentation using unsupervised machine learning. So the reason we are using unsupervised machine learning with this project is because With supervised machine learning, you know where you want to get to. In this sort of classification that we're going to do, basically what we are doing is we are giving some data to the machine and telling them to find out clusters, and for that we'll be using what is called KMeans clustering. So I've already explained you the concept behind it. So let's jump into the final implementation. So the first of all, we'll be importing pandas as PD, and then we'll be importing NumPy as NP. Following that, I have my customer data. So right now we are assuming that we are working for a company which provides credit cards. So we have some information on the credit card usages, and this primarily I've taken from Kaggle open databases. So let me just turn this off. And here we have the data stored on desktop, and it's called credit card customer data.csv. Now there could be some NA values. We will be replacing that with like a space, empty. So first of all, I would want to understand how the data looks. So customer data, this is how the data looks. So we have SL number, we have customer key, we have credit card limit, the total credit cards that were used, the total bank visits, the total visits that were done online, and the calls that were made. Your data could be different according to whatever information that you think is important for you to segment customers. You could just put it here. So I will first of all run a null check, which should be just cross verifying. Ideally it shouldn't be there because we will replace all the null values. So yeah, we have 0. And if you want to check how the data looks like, this is info telling you all our integer values. So there are no string values, so this is good for us. We don't need to do anything on this customer data. So the first thing we'll be doing is we'll be dropping some columns that we don't need and are not that useful for our analysis here. So for that, customer key, and there's another thing called SL number, which we don't need, and which will be done on axis 1. Okay, so now if I see my customer data, this looks like this. We have gotten rid of these two columns, SL and customer key. Alright, so now from sklearn, we'll be scaling this down. So if you see, these are running into 1 million records sometimes, so 1 million in terms of value. So basically what we're trying to do is we're going to standardize the scale of these values and these big values so that they do not take precedence over the other values here. So from sklearn dot preprocessing we'll be importing standard scalar. Okay, and we'll be preprocessing. Now scalar is equal to standard. We'll be initiating this scalar. So we have scale data now. Fit transform the data as well, and this data is again called customer data. So now if you see, we have some scale data. This data is normalized now, So let's move on. From sklearn.cluster, now is the final implementation. Import KMeans. Okay. So moving on, here we have the KMeans imported. Now we'll be importing matplotlib.pyplot as PLT. We'll be importing seaborn library as SNS. SNS. So now basically what we'll be doing is we'll be putting this inline. So matplotlib inline. So if you have different categorical distribution, categorical variables, like let's say for example gender is there, so it's always good to check what is the proportion of people that you're falling in one category over the other. This will help you understand the data much more, but I'm not going to go into that nuance right now. So here first off we'll be setting up SSE as an empty array, and then we'll be doing for k in range. So we are trying to give it a range of 1 to let's say 15. Okay, and we'll be drawing the elbow curve here, and for that we are trying to understand what KMeans does for different classes. So clusters is equal to k, and random state is equal to 55. KMeans dot fit scale data, and then SSE dot so for k in SSE you will have KMeans dot inertia. Alright, now we have PLT dot title, giving it a title. Let's call it the elbow method. We'll be putting the X label, K, Y label, SSC, and then SNS.pyplot. Let's do point plot X list dot keys. So all the keys will go in the X and all the values will go in Y. So keys are different values of K that we set up, and Y are the SSEs. This should work. And clusters, I guess it's clusters. Okay. Oh, okay. So the problem was here. It was SSE, not SEE, which is like a this is also SSE. I think I have not written SSE properly. Now it should work. Okay. So now you can see with the elbow method that the SSE, which is the SSE to the closest centroid, the cluster centroid, is decreasing till cluster number 3. After 4, this is, so 3 would be the ideal cluster basically here. And you could also go for 4 if that makes sense, but I think 3 is the best choice right now. Less cluster is 3. Best rather number of clusters is 3. Now for the model, we'll be using KMeans and putting n clusters is equal to 3 and random state is equal to any random number you could. If you put the same random state, you will get the same results actually, but there is no test range split, so there is no problem like that as well. Scaled data. Now model dot labels. Now these are the labels that the model is giving to different customers. So the first customer gets label 0, which is cluster 0, then 1 and 2. So there are 3 clusters, 0, 1 and 2 basically here. So you could do one thing, you could create a new data frame around this data frame and call this scaled data here, and this new df will be a data frame. Okay, now the problem is that it doesn't have the columns that we were earlier having, so we will add that. Also, if you want new, okay, so I need new df to have a new labels column. Okay, and it should come from model dot labels. Okay, now if you see, this new df has labels. Okay, now we'll be renaming the rest of the columns as well. New df dot rename. Okay, columns. Now it will be like this. 0 corresponds to average credit limit, 1 corresponds to total credit card, now 2 corresponds to visits in the bank, and 3 corresponds to visits, sorry, the first one was visits bank, so this one is online, and the 4th one is total calls, corresponds to total calls. The way I'm referring this is from the original data set. And 5th one, labels remains labels. Okay, now executing this. Okay, label here remains labels. Okay, okay, here it will be this and this. I have made one mistake. This is this. Okay, so if I now see new df, we have all the labels as well. Now we have done everything. It's just some computation just that I wanted to group by. Now you have all the customers. You could also plug in the customer ID to understand which customer is it, and seeing the labels you could define these 3 into different labels. But what I'm trying to understand and tell you guys as well is this. So if you put it to the original data set, that will give you a better picture of this, since these are normalized values. But what I'm trying to make you understand is all these labels have similar groupings of average credit limit, total credit card, and things like that. Okay, so if you have total labels aggregated into mean and count. Okay, so in the first label, in the first cluster, you have this is the average mean of the normalized credit limits. So better to do it this on the main data set to understand what is the average credit limit and what is the, and merge all the labels to the main data set. So ideally this should have not been on the scale database, but in the original customer data database. Okay, data frame rather. So last up, I just wanted to have a quick visualization of how this feels like. I will not be able to do it more than 3 dimensions. We just wanted to give you an understanding of how this looks like in 3D. So there is a new library that I'm importing, Access 3D here. Okay, so fig is equal to plt.figure, fig size is 2010, let's say, and then ax. So right now in 3D I can just only show you 3 columns. You could figure out, I mean, you could do it for other columns combinations as well. Subplot, I'll be adding a subplot here, 111, and projection is equal to 3D, 3 dimension. Okay, now axis dot sub scatter, in the subplot I have new df. I'll be giving the main sheet into for the raw Jupyter file and the dataset as part of my GitHub repo link in the description below. So if you want to try it out by yourself, you could do that. Average. So here what we are doing is we are taking the average credit limit and putting it on the new df dot labels new df the total credit card into the new df labels is equal to 0, and again the same thing, new df instead of credit card I want to see here visits to the bank, let's say. Okay, now I want this color to be blue and s is equal to 60. Okay, all right, so hold on. If we do the same here for one more cell, and okay, now this one is blue, this one is green, and this one is red. Okay, and okay, so for label 0, for label 2, 1 and 2, I want to show the same columns but for all the classes. Okay, in different subplots, I mean as part of the same figure, S is 60, which is the scatter, initialize this with 30 and 185, let's say. X label I'll put as average credit limit. Sorry for this. plt.y label credit card. plt.z label, rather ax set z label as visits to the bank. Okay, plt dot show okay, so we don't have dot in average, which is throwing an error here. Total credit card, this is written right. Visits to the bank. Visits to the bank. I think this should work. Okay, this is no, this should not be a problem here, but here is the problem. L is, so you guys have to just take care of these things while you're coding. All right, so you can see all the blues are a single cluster, the green one are the second, the red ones are the third cluster, and you can see that there are there's definitely also by just looking at it with naked eyes, you could be able to easily segment that. So my understanding of this is machine has done the right job of finding close enough points as a single cluster and identifying them as a single cluster. And as I said before, if you put this data along with your raw data that you started out with, which is the customer data, you should be able to get different segments and get the absolute raw values of average credit limit, the customer key, and things like that. And this is how you do customer segmentation with unsupervised machine learning in Python. I hope you've enjoyed this session, and if you've liked this video, make sure to subscribe to my channel, share this video with your fellow marketeers, and visit my website at ankitbagga.com for more such growth hacks and more such videos about new concepts in marketing. Thank you for watching this.